everyone. I hope you all are well. So, today I would like to discuss with you a topic is two component system by phase rule. As you know, what is two component system? When the two independent components are present in a heterogeneous system, the system is referred to as a two component system. Hence, according to the phase rule, for a two-component system having one phase. So, two-component system exists as a single phase and the maximum number of degree of freedom will be 3. So, F is equal to C minus P plus 2, where C is equal to 2, P is equal to 1 plus 2. That means 3. So therefore, two-component system having one phase will have 3 degree of freedom or 3 variable would be required to define the system. Means we need 3 variable to define the system. What is 3 variable? As you know, the 3 variable are pressure, temperature and concentration. So this will require a three-dimensional phase diagram for the study of two-component system. But in order to simplify the study, a two-component system is usually studied in the form of condensed system. So, a condensed system can be studied by reducing a comparatively less important variable. They reduce the degree of freedom of the system by 1 and the system can easily be studied with the help of two-dimensional phase diagram. So that means this requires three-dimensional graph which cannot be conveniently required on a paper. એટલે કે આપણે પેપરમાં 3-dimensional વાળો ગ્રાફ ડ્રો ના કરી શકે. So for any two of these three variable must be chosen for a graphical representation. We also discuss types of two component system where simple eutectic formation. What is eutectic formation? That means system contain two substances which do not react chemically. They are completely miscible in a liquid state but completely immiscible in a solid state is known as a eutectic system, or you can say easy melt, right? That means એક મિશ્રણ થઈ જશે બટ લિક્વિડમાં સોલિડમાં થશે નહીં, તો એને શું કહેવાય? eutectic formation. And in this system, different mixture of substance, a maximum having lowest melting point is known as a eutectic mixture. So it is a easy melt. So very low temperature it could be melt. Then after, binary alloy. What is alloy? Alloy is a mixing of two metals. A formation of compound with congruent melting point. That means system is to possess a congruent melting point when it melt at a sharp temperature and to give a liquid of the same composition as the solid. એટલે કે very sharp temperature liquid conversion થાય solid માં, but એનું composition કેવું હોય? તો કે original હતું એવું જ. તો the temperature at which such a compound melts is called congruent melting point. Now, formation of compound with incongruent melting point. So that is, system is said incongruent melting point if on heating it decompose at a temperature much below its melting point. એટલે કે એના melting point કરતા બી ઓછા તાપમાને melt થવા માંડે and form a new solid phase. અને એક બીજો જ કોઈ phase solid create કરે, and this liquid state has different composition from of the original state. એટલે કે એને original state કરતા એનું composition different હોય. So the composition temperature is known as a transition, or you can say meritactic, or you can say peritactic temperature. એટલે કે what is different between congruent melting point and incongruent melting point? So that is in a difference in a composition or in a temperature, right? So now what is reduced phase rule? Reduced phase rule કોને કહેવાય? In case of system consisting of only solid and liquid phases, small changes of pressure have very little effect on the system. એટલે કે a solid liquid equilibrium of any alloy has practically no gaseous phase, and the effect of pressure is negligible. So therefore experiments are conducted under atmospheric pressure. Such systems are called condensed system. As the F is such case is reduced by one pressure is taken as a fixed at 1 atmosphere pressure. Therefore, we can write a reduced phase rule equation as F dash is equal to C minus P plus 1. So 2 ની જગ્યાએ 1, so that means reduce, right? So the system which only the solid and liquid phase are considered and the gas phase is ignored is called condensed system. The equation is called reduced phase rule or condensed phase rule, right? So in our today's topic, we are going to study about lead silver system and its explanation, how beneficial it is and what is lead silver system. We will also read about some more topics like the eutectic point, the phase diagram of lead silver system, explanation of curves, etc. in detail. So take your notebook in your hand and get ready to study very simple diagram of lead and silver system. So the lead silver system is a two component system, as you know, that is two component system. Here two component present, lead and silver. The phase diagram of this system is lead and silver are miscible with each other in a liquid state. They are miscible in each other. What is state? That is liquid, and do not react with each other. એટલે કે this is a simple eutectic system, or you can say Perk method of desilverization, right? What you say? You can say also lead silver diagram or eutectic system or Perk method of desilverization. So it can have a maximum of following four phases. What is? First one is solid lead, second is solid silver, solution of molten silver and lead, and its vapor. So the boiling point of silver and lead are considerably high, and the vapor pressure of system is very low. So the vapor phase can be ignored. So here we ignored vapor phase. Why? Okay, vapor pressure of system is very low, and the system can be studied as a condensed system. So it is a condensed system. So we can apply here condensed rule or reduced phase rule. This system thus can be easily studied with the help of two dimensional T and C diagram of the reduced phase rule equation. So F dash equal to C minus P plus 1 can be used. This system is generally studied at a constant pressure. As we discussed above, we can draw a diagram temperature versus composition. So we take pressure as a constant. The phase diagram of lead silver system is shown in a following figure diagram. So this is a diagram of lead and silver system. The composition of lead taken on a x-axis and temperature on a y-axis. So you can see the diagram in the left side. We can take a lead is 100%. એટલે કે ત્યાં lead નું concentration 100% છે, and જેમ જેમ એ આગળ જશે એમ lead નું concentration 0% થઈ જશે. And you can say in the right side silver is 100%, and ધીરે ધીરે આગળ મૂવ થશો એટલે કે એનું concentration 0% થઈ જશે, right? So two lead and silver mix, but they do not react. So this is a eutectic system, right? Easy melt. Now in the right side, uh, 3 to 7 degree on Celsius, this is the melting point of lead, and another side 961 degree on Celsius, this is a melting point of silver, right? When we move further, the, then the concentration of lead is decreases at a point C, and another side when we move, the concentration of silver decrease at a point C, right? So this is a diagram, and at a temperature 303 on Celsius, we can draw a center line, and upon this center line, we can find these two metals in a solid form, right? So here 3 to 7 degree on Celsius is a melting point of lead, and 961 degree on Celsius is a melting point of silver. So you can see the difference in a melting point, right? What is the difference in a melting point? Okay, the melting point of silver is higher 961 degree on Celsius than the melting point of lead, right? So now we move on for our curve. What is curve? Now in a figure you can see the curve AC in the left side. Curve AC. The curve AC shows the variation of the melting point of lead on addition of silver. That means the pure lead melts at 320 on Celsius at point A. Now we gradually addition of silver, the melting point is decreases along with curve AC, and the added silver dissolve in a molten lead to form a lead and silver solution with the separation of some part of solid lead. Therefore, two phases solid lead and molten solution, lead and silver solution, remain together in equilibrium along with the curve AC. You can see the two phases. One is solid lead and another one is solution of lead and silver. Hence, phase is 2 and component is also 2. So C is equal to 2 and P is equal to also 2. So applying on a reduced phase rule, you can notice here we apply here reduced phase rule, not only phase rule. So you have to remember this. So F dash is equal to C minus P plus 1. So 2 minus 2 plus 1, this is equal to 1. The system is now univariant. So what is that means? What is univariant? That means the system, which means either temperature or composition must be fixed to define the system. Moreover, another one is curve. Sorry, I can tell you one thing. Curve AC, it is called the freezing point curve of silver, right? Now we move on further. Curve BC. Curve BC, or you can say CB, is the freezing point curve of silver. So as you know, the AC curve shows the variation of the melting point of silver on addition of lead. So now we graduate, and the silver melts at 961 degree on Celsius at a point B. Now we gradually add lead. It's lower its melting point along with curve along with curves C and B. So the add lead dissolve in a molten silver of Ag and Pb solution with the separation of some part of solid silver. Therefore, the two phases solid silver and molten solution remain together in equilibrium along with the curve Cb. Now, so here also what is the degree of freedom is also univariant, which means either temperature or composition must be fixed to define the system, because here also component is 2 and phase is equal to 2. So what is area? Area is B, C and A. You can see B, C and A. The area above the line BCF has a single phase, molten or liquid melt only. According to the reduced phase rule, F dash is equal to C minus P plus 1 is equal to 2. So the system is bivariant. So bivariant, that means both temperature and composition must be fixed to define the system completely. Now area DCFH. You can see area DC and F and H. The area also has two phases, which are solid Hg crystalline and solid eutectic crystalline. Hence C is equal to P and C is equal to 2 and P is equal to 2. The system is here univariant, right? So another area is CEGD. You can see in the figure, the area also has the solid lead crystalline and solid eutectic cis crystalline phase. The system is also univariant. So now also important point C. This is called eutectic point. So what is this? That the curve AC and CB meet at point C at a temperature of 303 degree Celsius, where three phases solid AG, solid PB and the liquid melt are in the equilibrium, right? So according to reduced phase rule, F dash is equal to C minus P plus 1 is equal to C minus 3. Here three phases available. Which one? I tell you, FG, and its melt, right? So degree of freedom is 0. So that is called univariant. Sorry, this is called non-variant. The point O is called eutectic point or eutectic temperature, and its composition is 97.4% Pb plus 2.6% Ag. It's called eutectic composition. Below this point, એટલે કે 303 અંશ is the melt solidify, એટલે કે solid form માં ફરીથી convert થઈ જાય, right? So some silent features of this system I can tell you. So this is a diagram, curve, area and point, name of the system, phase in equilibrium, number of phases and degree of freedom. You have to remember only this table, right? So first curve AC. You can see the curve AC is a freezing curve of lead, and here what is phases? Okay, lead and melt, lead and silver. So number of phases 2 and the degree of freedom is 1, that is univariant. Another one is curve CB. Curve CB is freezing curve of silver. Here also silver and melt. And so number of phases 2. So that is called also univariant. Another one is area ACE. Lead and its melt. Degree of number of phases 2 and degree of freedom univariant. Another area is BCF. Here silver and melt, phase in equilibrium, number of phases 2 and degree of freedom 1. Now ACB, this is only one and bivariant, right? And point O is a eutectic point, and here three phases available, lead, silver and its melt, and number of phases 3. So degree of freedom is 0, non-variant, right? So here also one important point of desilverization of lead, or you can say partition process. So first of all we need to know about what is the desilverization. Desilverization means in a chemistry we put D in a word, so it is called remove. For example, we can write a reaction of decarboxylation. That means the removal of carboxylation. Dehydration, that means removal of H2O. So here desilverization of lead. So that means lead માંથી desilverization એટલે કે silver ને અલગ પાડવાની method. So this is called partition process. In a paper, uh, you can they can also put like question desilverization of lead, partition process, or eutectic system. So you can write lead and silver system, right? So what is desilverization of lead? So the process which used for the recovery of silver from argentiferous lead, it is called desilverization of, or you can say partition process, and it involves the desilverization of lead in the phase diagram of lead and silver system, right? Lead કેવો હોવો જોઈએ? Argentiferous. So the argentiferous lead contains a small percentage of silver, less than 0.1%. For the recovery, the argentiferous lead is heated above the melting point when a liquid melt consists of a silver and lead solution is obtained. So now if the silver lead solution is cooled, first we heat the solution, right? Then it cooled, then Pb contains a separation out and is regularly removed. So now if the silver lead solution in the end a eutectic solution contain 2.6% Ag, it's obtained. Thus the above process increase the percentage of silver in the argentiferous lead. So therefore eutectic mixture contain 2.6% silver can be treated of the recovery of silver profitably, right? So an argentiferous lead contains a small amount of silver. For the recovery, it is heated to a temperature above its melting point, and so the system has only a liquid phase, represented by the point C in the phase diagram. So in allowed it to cool, while the temperature decrease along with an S to N as the point C reach, lead is crystallized out and the solution will contain increased amount of silver. So on a further cooling, more and more the lead is separated along with line and the melt content to be richer and richer in Ag until the point O is reached, where the percentage of Ag rises to 2.6%, right? So now use of eutectic system. So suitable alloy composition can be predictable, એટલે કે alloy ના composition કયા ટેમ્પરેચરે કયા છે એ ભી આપણને ખબર પડી શકે from eutectic system. So what is melting point? So in the temperature at which the solid and liquid phases having the same composition are in a equilibrium, so it is called melting point. Now what is eutectic point? So it is the temperature at which two solids and a liquid phase are in a equilibrium. So it is called eutectic point. And what is triple point? It is the temperature at which three phases are in a equilibrium. That is called